On the morning after Christmas 2004, the Indian Ocean seemed calm until, in just minutes, the sea floor tore open beneath Sumatra, releasing more energy than every nuclear test in history combined. Without warning, a wall of water 30 meters high obliterated the city of Banda Aceh, killing over 100,000 people in a single hour. This wasn't just a natural disaster. It was the deadliest wave you've never heard of. An event so powerful it shifted the Earth's axis and shortened our days. But how could one hidden rupture trigger global chaos on this scale? The answer starts deep beneath the ocean's surface. At 7:58 a.m. local time, the Indian plate lurched beneath the Burma plate, miles below the Indian Ocean. The rupture didn't tear in a single instant. Instead, it raced northward along the fault for nearly 8 minutes, unzipping the seafloor at speeds close to 2.8 kilometers per second. That's faster than a bullet train, but for a geological event, it's a drawn-out process, long enough for seismic waves to circle the globe multiple times before the last segment slipped. The fault line itself stretched over 1,600 kilometers, from the deep waters off Sumatra all the way toward the Andaman Islands. In some places, the seafloor heaved upward by as much as 6 meters, while other patches dropped away, leaving fresh scars across the ocean floor. This sudden reshaping of the seabed displaced billions of tons of water in a matter of minutes, setting off a chain reaction that would cross continents. Scientists refer to this type of event as a mega-thrust earthquake. Here, two tectonic plates grind together under immense pressure for centuries until, finally, the strain becomes too great. When the fault gives way, the energy released is staggering, equivalent to 23,000 Hiroshima bombs detonating at once. The planet itself felt the shock. NASA satellites later measured a shift in Earth's axis by 2.5 centimeters, and the day shortened by nearly 7 microseconds. As the rupture line zipped north, the ocean above responded instantly. The vertical movement of the sea floor forced the water column upward, launching a wave that would travel at jetliner speeds. The true consequences, though, were still hidden beneath the surface, racing outward in every direction. By 8:15 a.m., Banda Aceh was already unrecognizable. The wave that struck the city was not a single crest, but a wall of water rising over 30 meters in places, higher than a 10-story building. The force of the tsunami erased entire neighborhoods in seconds, pulling concrete, trees, and vehicles inland before dragging them back out to sea. In some districts, no structure remained standing. The coastline itself shifted, with landmarks wiped from the map and streets now buried beneath thick layers of mud and debris. Survivors describe a silence after the roar, broken only by the sound of water receding and the cries of those stranded on rooftops or clinging to palm trunks. The Baitur Rahman Grand Mosque, battered but still upright, became a refuge for thousands who ran from the surge. Many reached safety only by split-second decisions, running upstairs, grabbing onto pillars, or climbing scaffolding as the water rose around them. For most, there was no warning. The sea had vanished, then returned as a force no one could outrun. In less than 20 minutes, nearly 100,000 people were lost in Aceh alone. The scale of destruction defied imagination. Entire families missing, entire communities erased. The run-up heights, measured by field teams in the weeks after, reached the highest ever recorded for a tsunami in modern times. In the aftermath, survivors wandered a flattened landscape, searching for loved ones among the ruins. For Banda Aceh, the disaster was not just measured in numbers, but in the absence left behind. At 10 years old, Tilly Smith stood on Mai Khao Beach in Thailand and noticed something was wrong. The ocean had pulled back, leaving fish flapping on the sand. The surface frothed with strange bubbles. Most people watched in confusion, but Tilly remembered a school lesson about tsunamis. She pleaded with her parents to leave the beach. Her father flagged down resort staff, and within minutes, whistles and shouts cleared the sand. Around 100 people escaped to higher ground before the first wave arrived. For them, disaster was measured in what didn't happen. No one on that stretch of coast lost their life. Across the Indian Ocean, a packed train known as the Queen of the Sea rolled along Sri Lanka's southern coast. Passengers leaned from windows, watching the sea retreat. There was no warning, no siren, no urgent call from officials. The first wave struck, flooding the tracks and stalling the train. Some passengers climbed onto the roof, hoping for safety. The second wave arrived minutes later, taller and faster than the first. It lifted the carriages from the rails and hurled them into the trees. Over 1,000 people died in that wreck, the deadliest train disaster in history. The difference came down to knowledge and systems. On a Thai beach, a single voice, armed with a classroom memory, was enough to change the outcome. In Sri Lanka, even with heroic efforts by the train crew and local station masters, the lack of any official warning left no time to escape. When the ocean gives only minutes, the gap between knowing and not knowing can mean hundreds of lives. 7 hours after the seabed ripped open near Sumatra, the wave arrived on the far side of the Indian Ocean. Along the Somali coast, fishermen prepared for another ordinary day. No warning reached the villages scattered along the sand. The sea receded, leaving boats stranded on mudflats. Some men ran out, hoping to salvage their nets. Then, without sound or signal, water surged back in, a wall 5 to 6 meters high, moving faster than anyone could run. Hundreds of boats were lifted and smashed against the shore. Villages that had stood for generations vanished in minutes. Timber and thatch swept deep into the interior. Tide gauge records from Mogadishu and Mombasa later confirmed the scale. Not one wave, but a train of surges, each arriving with eerie precision, hours apart. The second and third waves were often higher than the first, catching those who had returned to salvage what they could. In Lamu and Hafun, entire fishing fleets disappeared. The death toll in Somalia alone topped 300, with many more missing, their names never recorded. For families who lived by the rhythm of tides, the ocean's pattern was broken. The wave that began near Sumatra had crossed 4,500 kilometers of open water, transforming from a deep-sea ripple to a force that erased coastlines on another continent. By midnight, the Indian Ocean's pulse was still unsettled, with distant gauges in Kenya and Tanzania reporting delayed surges. The disaster's reach had circled half the globe, leaving behind not just destruction, but a new understanding of how a single event could bind distant shores in shared loss. Grace satellites and global GPS networks tracked the planet's response in real time. The earthquake shifted Earth's axis by nearly 2.5 centimeters, a change confirmed by NASA's geodetic analysis. That sudden redistribution of mass also shortened the length of a day by almost 7 microseconds, a fraction of a blink, but a measurable effect on the planet's spin. Seismic data and satellite gravity readings documented subtle changes in Earth's field, visible only through the most sensitive instruments. For geophysicists, the 2004 event became a rare case where a single rupture left a fingerprint on the entire planet. In the wake of devastation, new systems took shape. By 2006, a network of deep ocean buoys and real-time seismic sensors began monitoring the Indian Ocean, designed to give coastal towns precious minutes of warning. International agencies, scientists, and governments worked together, launching drills and public education campaigns that reached millions. In Indonesia, the aftermath brought negotiators from Jakarta and Aceh to the table. The 2005 peace agreement ended decades of conflict, a treaty signed in the shadow of shared loss. Out of disaster, new lines of communication and hope were drawn. On December 26, 2004, a 9.1 to 9.3 magnitude earthquake off Sumatra triggered a tsunami that killed over 230,000 people across 14 countries. The rupture lasted nearly 10 minutes along a 1,600-kilometer fault, one of the longest ever recorded. Footage and tide gauge records show how the tsunami changed as it crossed the Indian Ocean, destroying Banda Aceh within minutes, derailing a train in Sri Lanka, and reaching African shores 7 hours later. Despite detailed seismic data and survivor accounts, the precise reasons why some communities received little or no warning remain under investigation. In response, a regional tsunami warning system was launched in 2006, and the earthquake's force shifted the Earth's axis by 2.5 centimeters, shortening the day by 6.8 microseconds. Today, the legacy of the 2004 tsunami is measured in new safety protocols, scientific advances, and lives saved by early warning. The evidence is clear. One event can reshape nations, science, and even the planet itself.